All right, so the last time that we met, we started talking about writing classes. So I'm going to continue with that, and I'm just going to kind of do like another example. And I'm going to give you guys like a quiz to do where you write another class before I actually start the lecture. So let's just think about a shape, all right? So look, a really easy shape is a circle, all right? So here's a circle. I'll just label it circle. And some of the instance data that a circle will have, or can anybody think of like what data a circle will have? Just a generic circle, like there's no color or anything, just measurement. What's that? Okay, so that would be a service of the circle class to whenever you wanted to know circumference, that value is provided to you. Okay, so yeah, actually that's a good one. Okay, so you would have something for circumference. Okay, what else?
Radius.
All right, so radius would be what we call instance data, meaning it's data that you want to protect. So yeah, I do agree with you. You would either have radius or diameter, one of the two, right? All right. I kind of messed that up, but all right. So like what other things are there about a circle?
Center.
Sorry, what's that? The center. I guess if you're putting it onto like a graph, then yeah, like you would have like a center point of where it starts, but we're not going to be doing that for this example. Okay, yeah, area is a good one. Area. So remember these little lines, oh, what the heck? These little lines coming off, oh, I don't know what I'm doing. Come back. Okay. These little lines coming off, this are like services that it provides, which are the methods. So we're going to provide area. Okay, that's a good one. All right, some of the other things too is we want to get and set the radius, right? So you're going to have like a get radius and a set radius. All right, what about diameter? Do you think diameter should also be part of the instance data? All right, so either one or the others, right? So it's one of the things where you don't want to really have data for diameter if you're going to have data for radius, because one can be calculated off the other, but somebody might actually want to know what the diameter is. So it's another service that you might want to provide called like, calculate diameter, So I'm going to put here calc diameter, and that's simply just going to take radius and multiply it to 2. Okay, so here is like a blueprint for our object that we were going to write. All right, we're going to take this information, we're going to write a class, we're going to call it circle, we're going to have instance data for radius, we're going to have a getter and setter for radius, and they're going to provide these methods right here that are going to calculate circumference, calculate area, and calculate diameter. So I'm going to go ahead and open up Notepad++. And I am going to get new. All right, so this is going to go under chapter 4, and we'll call this class circle. All right, so this is a blueprint for an object. It's going to be public class. There's going to be no main method. Okay, we're going to have the name of our class up here, which is circle. And we're going to have instance data that we're going to track for the circle. So the only thing that we came up with was that we should have instance data for our radius. I'm going to say that the radius can be a float because there could be like a fraction, like your radius might be like, depending on our unit of measurement, it'll be half of that unit, right? Like you can have like a 0.5 or a 1.5 or 1.3. Okay, so I'm going to say that it's float. And I'm going to go ahead and make a constructor for my circle. So just like we did for the die and the coin, we want to initialize radius to some value. Now, does it make sense to set radius to 0 when we first instantiate a circle? Right? 'Cause to me, it's weird, right? Like something that has dimension should never have a 0 for the value of a dimension, right? There should always be something there. So these are one of these classes that it doesn't really make sense to create a circle unless you know what the radius is, right? So what we're going to do is we're going to make our constructor accept a float, and then we're going to take that float and we're going to use that float to set what our radius is. Okay, so up here, I'm going to say float, I'm going to call it R. So in our constructor, we're going to expect a float to be passed in, and we're going to take that value and we're going to set radius equal to that value that was passed in. All right, and then for now, we'll just do our getters and setters. So we'll say public void set radius. And we'll also take in a float here. We'll just put a value for the radius. And we'll do the same thing that we did in our constructor, where we simply just take in that value and set radius to R. Then we're going to have one for getting the value. So we're going to return the radius. The radius is a float. So it's public float get radius. And we're simply just going to return whatever radius is. All right, so I'm going to make a class called test circle. Or I'll call it circle test. This is the class that is going to have the main method, public class circle test, and then public static void main string array arguments. All right, so from here, what I'm going to do is I'm simply going to instantiate a circle. I'm going to say circle C is equal to new circle. Now I did specify that I needed a float value inside of my constructor, but I'm going to leave it like that for now so that we can see what happens when we instantiate it. And then I'm just going to just simply do a system.println and just say radius of the circle is, and then print out c.get radius. All right, so I'm going to compile and run this. I'm going to come here and then go to containing folder cmd. All right, so from here, javac.circle test. Okay, so it didn't compile. All right, so let's read this error that we've created. It says circle test.java on line 3, that's what that 3 means. Constructor circle and class circle cannot be applied to the given types. Okay, required a float but found no arguments. Okay, so what Java is telling you is you try to instantiate a circle, but when it goes over to this blueprint for the circle, it's seeing that a float needs to be passed into the constructor, right? Because we created our constructor to take in a value, but when we actually used the constructor, we didn't, so we had this error where it didn't compile. Okay, so we need to put a float inside of that value, or inside of that constructor. Okay, so I'm gonna come over here and I'm gonna do 9.5. Okay, do you guys think this is gonna work? 9.5. Like, what is 9.5? Like, what is Java C 9.5 is? What type of data? A double. So a double is how many bits? 64. And my constructor says I want a float, which is 32. Okay, so Java is going to complain again when I come over here to compile. All right, and it's just telling it's a different error this time. It's telling me incompatible types, possible loss of precision. Right, you're going from a double to a float. So once you do, it's basically saying this constructor accepts a float, but you're trying to give me a double. Okay, so this is what we call a double literal. Remember that from chapter 2. That is going to be a midterm question. So if I want to make a float literal, what do I need to do? F, right, at the end. Okay, so now Java is going to be happy. I'm going to clear my screen. Dang it, compile. I'm going to run. Okay, and I just printed out the radius of the circle. All right, pretty simple. So this is my test class, right? So the whole idea behind the test class is you instantiate your object and you just run a few tests on your object to verify that you're getting the expected results whenever you're using this circle. So I'm gonna come over here, I'm gonna say c.set radius. I'm going to pass in a new value. So I'll pass in 1.5f, and I'm going to print out my value. Compile. Right. Okay, so the radius was 9.5. Now the radius is 1.5. All right, so some other things that I need to do to this class is perhaps put a toString method. If you remember the last time we talked, we did say that every class always inherits from the underlying object class. Right, that's just a generic class that Java created, and it has already a toString method. So if I were to say system.out.println and say circle, and it said toString, or I can also just print the object out without calling the toString. It's automatically invoked, so I don't really need to type out .toString. Okay, if you hop back over to the circle, these are the only methods I have defined, right? The constructor, the set radius, and the get radius, right? I don't have any toString method defined. So now when I hop over here, compile, and run, okay, the output from the toString was this. Okay, and the reason why it didn't like throw a compilation error is because it inherits from an object class. The object class has the toString created for it, but it's going to do its default behavior, which is printing out the class name and the address of where that object is located in memory. Okay, so whenever we call it toString, or whenever we just print our object directly to the console, then we're going to get the underlining toString object. So I have to come over here and I have to create a new toString that I think would be what we call overwriting. Create a new toString that is going to be give me like more pertinent information for this circle object. So I'm going to say public string to string, open close parentheses, open close curly braces, return, and I need to return some type of string that is going to give me a preview to what that object is, like what the data is actually set to. Okay, you can return any string. I could just say like, hello, this is the toString method. When I save that and hop over to compile and run, you can see now that it's taking the string that I put into the circle class. All right, we should put something that is meaningful to, that's going to capture the state of the object. All right, and perhaps we just specify the name of the class, circle, and what the radius is equal to. Actually, I'm going to use the toString, the string format. All right, so I'm going to say string.format, and then %f for where the float's going to go, and I'll put in my radius. All right, so now when I compile and I run, there is my new toString. Right, it's telling me the name of the class and what the radius is equal to. All right, let's look back at what we created when we drew it up. So I'm still missing some services here. So I did create a few of them. Dang it, I can't unclick this. All right, so I did create a few of them. Okay, the ones I created were the get radius, the set radius, and that was it, right? So the ones I need to create is something for diameter, something to calculate circumference, and something to calculate area. All right, so the easy one, the low-hanging fruit, is the diameter. So I'm going to hop over to my class, and if I ever wanted to know diameter, what is the equation to convert radius to diameter? Anybody know? You just take radius, whatever radius is equal to, and multiply it by 2. So I'm going to make a new method that is going to return a float. I'm going to just call it diameter. Okay, it is a method and it is not instance data. Students come up here and say, oh, I need a variable for diameter, and they throw it up there. That is completely wrong, because since like one of them, like radius or diameter, one of them is dependent on the other, right? If you change one, you're gonna have to go change the other if you're trying to track it as instance data, both of them as instance data. whatever one you decide to track, you're going to have to make a method to calculate the other one. So in this case, I'm making one for a diameter, so I'm going to say return whatever radius is multiplied by 2. All right, so now what I can do is hop over to here and just say system.out print line. The diameter is and c dot diameter. Come over here, compile, run. All right, and it was 1.5, so I can see that my diameter is 3. All right, pretty simple. All right, so the other two aren't so simple. You're gonna. I don't have the equations memorized, but I'm gonna make one for. It's gonna return a float, or maybe even a double. Depends on how you want to do this, right? Like if you rather do double, so you don't have to do casting and all that, because we could probably just use math.pow, because I believe one of the equations takes the radius to the second power, or maybe it's just multiplied by 2. I can't remember. But anyways, I'm going to use float, so I'm going to say public float, and I'm going to call this circumference. All right, I can call it calculate circumference or just circumference. It doesn't matter. I'm going to return a value, and that's whatever the equation is. I don't know the equation. I'm just going to go to Google and then type out circumference of a circle. All right, and it's 2 times pi times r. Pretty simple equation, okay? So where I have my circumference in my return, I'm going to take 2 times pi, the math class has a pi, math.pi, and then times radius. All right, so now what I'm going to do is I'm going to copy what I did here, slap it there, and just call the method circumference. All right, and I'll copy that there, and I'm going to go ahead and print both of these out. When I first instantiate, I'll slap it there, and then I change the radius, I'll slap it there. I'll go ahead and remove it from the bottom. All right, so when I have 9.5, I'm going to show what the diameter and the circumference is, and then when I have 1.5, I'm going to show what the diameter and the circumference is. So come back over here, compile. Dang it. Oh, so this is the problem I was telling you about. I am saying I'm going to return a float, but math.pi is a double. So you have that possible loss of conversion because you're going from a double to a float. So this is where we're going to have to use casting. So what I'm going to do is just wrap this in parentheses and cast that value to a float. All right. Compile and run. So when it was 9.5, diameter was 19, and this was my circumference. Okay, when it was 1.5, diameter is 3, and this is my circumference. All right, so it's always good to just check your work. So I'm going to come over here, and I'm going to plug in those values right here. So I'm going to say the first time our radius was 9.5, we got 59.69, and that's pretty much what they got, right? Then we also had 1.5, type in 1.5. They got 9.42 for their circumference, and they're 9.42, and we got 9.42, pretty much the same thing. Okay, so it's always good to check your work to make sure your calculations are correct, because I will be checking them when you turn your work in. All right, so let's finish off this class. So the last thing that we have to do is add a method to calculate area. So I'm going to make a method called public float area, and this is going to return a value. I'm going to go ahead and just cast the float now because I know it's something I'm going to have to do. And then I'm going to put in my equation right there. I do not, what is it? Pi r squared. Okay, so I'm going to say math.pi, and then I'm going to multiply it to math.pow. And I'm going to pass the radius in, and I'm going to take it squared. I'm passing it to Okay, so this is pi, and this is r squared. Okay, we have the math class that will do a lot of the heavy lifting for us. So there is my area that I'm returning. I'm going to come over here and I'm going to just copy what I did there. And I'll just change this to area. All right, and I'll come over here on my screen, compile, run, and my area is 283.52, and when it was 1.5, the area was 7.06. I would like to check that, so I'm going to come over here. I'm going to put area of a circle. All right, and I'll just type in 9.5. All right, and that's what I got. And then I'm going to type in a 1.5. All right, that's what I got. All right, pretty simple, right? I mean, this does take some planning on what data that you're going to try to maintain. I don't know if I talked about the whole constructor thing where you pass in a value, but that is something that we can do where you don't want to have a circle object unless they give you the radius, right? That makes sense because you don't like if a circle doesn't have a radius set, then it's not a circle, right? Whatever instance data you have, you're going to have getters and setters, right? So I had a radius, there's my getters and setters. And then you have some other services that you provide where you're actually performing some calculations. There's diameter. Oops, I have my toString in there. I always throw my toString at the very bottom, like just so it doesn't get in the way of what I'm trying to do. Yeah. So we have three methods that are going to do some calculations for us. The first one just gets the diameter. Second one calculates and returns circumference. And the next one calculates and returns area. All right, any questions on this? Okay, so you have till 7:30 because I do want to lecture. Like I do want to open the PowerPoint and talk through a few slides. You can finish it after class or after I'm done lecturing. But here is the quiz 6. So what I want you to do is write a class name square. Let me edit that. All right, so write a class named square that has instance data for length, which holds a float that indicates the length of one side of a square, right? So a square has equal sides, right? So you're only going to take in a length for one side, okay? Just like we did for the circle. You can have a getter and setter for that length. I also want you to override the toString method, and you're going to have a method to calculate area, or you can just call it area, and calculate perimeter, or you could just call it perimeter, right? Those are going to look pretty much similar to these, except the equations are going to be a little different, right? So the area of a circle, or excuse me, area of a square is length times length, right? Or length squared. And then the perimeter is length plus length plus length plus length, which is 4 times length, pretty much, right? So those are the equations for that. I did write them down inside of this quiz, right? So I tell you the formula for area is this, and the formula for perimeter is this, all right? So once you have your square class done, then I want you to write a driver class that is going to test the set length, the get length, the calculate area, the calculate perimeter, and the toString method. Similar to what I just did for the circle. All right, so try to do that for the next 25 minutes. And I am going to be grading this, so it does need to go in Dropbox. I'm sorry, what's that? Oh, I do want to, I didn't put a constructor. Let me see. So write a class name square that has instance data for length. Okay, you're right. So let me just put that in there. Create a constructor that accepts and initializes. Wait, initializes. Dang it, what the heck? So accepts and initializes length. All right, accepts a value and initializes length, just like what I did for my circle. Okay, so before I start lecturing, we need to talk about the midterm. So the midterm will cover chapters 1, 2, 3, and 4. The spring break is next week, right? It normally takes me about 2 weeks to finish chapter 4. We started actually last week, one day last week. So after spring break is the 16th. So we'll probably have the week of, probably have it on 25th, just because I don't like to give it, I can need time to grade it. But I think the 18th would be too soon, yeah, or too soon from spring break. So I have it on the 25th. Is a midterm, but it seems kind of weird because that's like, we only have one more month after that, or maybe like a month and a half after that, right? So, all right, then once we're doing chapter 4, we're going to talk more about chapter 4. It's going to get like, we'll probably be in chapter 4 for all of March, the rest of March. But I'm going to like test you on chapter 4. We're going to have a midterm. And then after the midterm, like we're also going to talk a little bit more about chapter 4. And then all of April, or the rest of the semester is going to be chapters 5, 6, and part of chapter 8. Okay. All right, so that's like the rest of the semester. I was walking around, I'll see people struggling. Like, you need to understand this for the midterm. Like, if you're not getting it, you need to go see the tutor. You need to practice every day, write out your code, try to get away from copying and pasting. Just try writing it first without looking. Like, just think about what you need to write and to try to do it that way. And then, then you can go back and look. On the actual midterm, you are going to have to write code down, like without being able to reference a book or the internet or anything. You just got to know how to write it. Like, I'm going to ask you questions like, write a class for a student that has instance data for first and last name and 3 test scores, right? Like, that's, you'd have to know, like, okay, I need a string for first name, a string for last name, float or double for test 1, test 2, test 3, and then like you need all the getters and setters, right? That's just what we call boilerplate code. It's just something you just do over and over and over again, right? So you're gonna need getters and setters, you're gonna need your toString, and then I'm gonna ask you to do something like make a method that calculates and returns the students. Well, actually, no, I think that's your final exam question. But anyways, make a method that calculates and return test average. I believe the one on the midterm is either the dog one, right? You have a homework problem about writing a class for a dog. It's either that one or I think the rectangle one. I can't remember now, but I have to look. But anyways, you are gonna have to know how to do this like just straight from memory. I know it seems like overwhelming, but you do, because of spring break, you actually have a long time, like till March 25th, to like know how to do this. Okay, if you're struggling, go see the tutor or just keep practicing. Yeah. Yes.
So that's like all the midterm will be is just you give us an example or like you tell us what to do and then we just do it right now.
No, it's actually a test. There's going to be like multiple choice questions. There's going to be like short answer where I'm going to have like some code that you're going to have to analyze and figure out what the result's going to be. And then there's a section where you're going to actually have to like type out code from memory. Like just know how to like write it out. So, yeah. Like one of the common problems is prompt the user for his first and his last name, then generate a username with a random number between 10 and 99. The exact problem from the homework, right? Like just, we did a quiz on that one as well, right? So just questions like that. I will like I do give a review for the midterm. So as it approaches, I will the review on Dropbox, and you can study from that. But now's the time to start thinking, like, if you're not getting it, I know there's students that haven't even shown me chapter 2 homework yet. And if you haven't shown it to me because you haven't actually done it, then you're probably going to end up failing this class. Like, that's just statistics. I've taught this for a long time. If you're not understanding chapter 2, then at this point it's probably too late for you. So either you like bust your ass over spring break trying to get up to par, or just, I don't know, withdraw and take it again next year. But be more prepared next time, right? Like, I mean, it's a lot of homework. I know, I get it. It's hard, but it's programming, right? So, I mean, programmers make a lot of money. It's not for no reason. It's because they have to understand this stuff, right? So, just keep that in mind. All right, so I'm gonna go ahead and start on chapter 4. I'll probably try to get through the first 2 sections, maybe just the first one. Okay, so see, chapter 1, writing classes, right? I did a bunch of examples the last class, and then I did the one on the circle one. We're going to keep just doing examples and doing quizzes every day. All right, so I'm going to just read this slide. We've been using predefined classes from Java API. Now we'll learn how to write our own class. Chapter 4 focuses on class definitions, instance data, encapsulation, Java modifiers, method declarations, and parameter passing, constructors, and then we're not going to talk about arcs, images, event handling, buttons, and stuff like that. All right, first section. Okay, now chapter 4 does seem like a lot to understand, but if you're actually looking at the book, we're only covering the first 3 sections of chapter 4, so you don't actually have to cover the entire chapter. The concept is difficult, but the content from the book it's only half of the chapter. All right, so what's highlighted is what's going to be on your midterm, right? And then the GUI stuff, the graphical stuff is not going to be. We're not going to learn that in this class. All right, so writing the class. The programs we've written in previous examples have used classes defined in the Java API. Now we'll begin to design programs that rely on classes that we write ourselves. The class that contains the main method is just the starting point of the program. True object-oriented programming is based on defining classes that represent objects with well-defined characteristics and functionality. And then here they give you examples of classes. So they're saying if you're going to make a class for a student, then perhaps you'll have a name, an address, a major, and a GPA, right? And then some operations would be the getters and setters for all that stuff, and computing the GPA. Rectangle, they're saying you would have, when they say attributes, they really mean instance data, right? So the rectangle would have a length, right? Also a width, right? Because the rectangle just does not have a length, it has a width as well, because the length and the width on a rectangle are different. So length, width, and then they added a color. Okay, and then they have the getters and setters for all that. You would also probably have perimeter and area of a rectangle as well, right? Those are some services that you would probably provide through the methods. They have a class example for an aquarium, for a flight, and for employee. It's just all thinking about what type of data you would track for each one of those objects, right? Aquarium, they said material, length, width, and height, right? So the aquarium is almost like a cube, like a rectangular cube where you have a length, width, and height. And then they have your getters and setters, and then they have some methods to compute volume and stuff like that. Flight, employee, I mean, those are pretty generic, actually. I think the flight one's in your book, or in the homework assignment. You would have a flight number, destination city, origin city, and I can't remember what else. Status, maybe? I can't remember. But you have getters and setters for all that. And then they have the employee. Name, department, title, salary, and then they have getters and setters for that. We call from our overview of objects in chapter 1 that the object has a state and behavior. Consider a 6-sided die, singular for dice. Its state can be defined as the face value, or which face value is showing. Its primary behavior is that it can be rolled. We represent the die by designing a class called die that models this state and behavior. The class serves as a blueprint for the die object. We can then instantiate as many die objects as we need for any particular program. Okay, so here they're giving you how a class is laid out. So a class can contain data declarations and method declarations. So up top you'll have your data declarations, that would be your instance data, And then below you'll have your method declarations. The values of the data define the state of the object created from the class. Okay, so when I say state of an object, it just means like what values are currently stored inside of its instance data. So for a circle, if we look back at the circle and we look at the test class, we gave it 9.5. So the state of the radius was 9.5 whenever we output it, right? Change it to 1.5 so its state changed. Its behaviors are the methods that we invoke on it, like the get radius, get diameter, the circumference, and the area. Those are the behaviors or the services that it provides. Let's see, is that where I was at? So the values of data define the state of an object created from the class. The functionality of the methods define the behaviors of the object. For our die class, we might declare an integer called face value that represents the current value showing on the face. One of the methods would roll the die by setting the face value to a random number between 1 and 6. We want to design the die class so that it is versatile and a reusable resource. Any given program will probably not use all operations of a given class. And then they give you their example of how they did it. Through those slides. So let me just pull that up. Or actually, we can just look at what they did. Okay, so they had the rolling dice, which is the driver because it has the main method. And they instantiated, or they declared 2 object reference variables, die 1 and die 2. And down here is when they did the instantiation. And then they made an integer for sum, which is going to hold the sum of the 2 die. They invoked the methods roll on die 1 and die 2. They outputted the values. They rolled the die again. They set the face value, or rolled die 1. They set the face value die 2. They outputted the values. They got the face value of die 1 and the face value of die 2. They summed them, and they stored that value into the variable sum. And they printed out what the sum was. And then they, in their method, the roll method I created, we return void, meaning there is no return type. But the one they created, it looks like they're returning a value from roll, meaning you can get the face value through the roll method, and then they output the whatever values. Actually, in these system.println, they're just basically calling the toString, right? Whenever you put the object, concatenate it to another string, it's going to automatically call the toString method. And here's their output, and then here's the class that they designed. So they said public class die. They had a constant for the max number of sides. They had instance data for face value. In their constructor, they initialized face value to 1. Their roll method right here, you see how they're returning an int? I believe the one that I created was not doing that. Let me look really quick. So die. Right here, here's my roll method where I'm saying public void. Now, whenever you do void, that just means that there's no value coming back from that method. Whenever you put a data type that you're going to return, like you did for get face value, that means that you're going to return a particular data type. So for get face value, you're going to return an int, and for toString, you're returning a string. My roll method, I wasn't returning anything, so I just did void. But the roll method from the book, they put an integer as a return type, and you can see what they did is they calculated the face value, and then they just returned the face value from the roll method. They have the getters and setters. They call them accessors and mutators in the book. I've only heard them refer to that in this book. Right, and those are just the getters and setters, right? So you set the face value, you take in some value, you set face equal to the value passed in. Get face value simply just returns the face value. So whatever the data type of face value is what you want to put as the return type. Okay, the die class. Now they're going to explain like every little thing they did to the die. So the die class contains 2 data values. It has a constant max that represents the maximum face value, and an integer face value that represents the current face value. I don't know if I used the constant. Did I? No, I didn't. I just used 6 right here. All right. The roll method uses a random method of the math class to determine the new face value. There are also methods to explicitly set and retrieve the current face value at any time. The toString method. It is good practice to define a toString method for a class. The toString method returns a character string that represents the object in some way. It is called automatically when the object is concatenated to a string or when it is passed to the system.out.print, print line, printf. Okay, it's called automatically. It's also convenient for, actually, did I say printf? I guess, I take that back. It's probably not called automatically for printf. I would have to play with it, find out. Anyways, where did I leave off? It's also convenient for debugging problems. Okay, so that's, to me, this is the big benefit of using the toString method, is you can get a preview of what is actually set, right? What your instance data is actually set to inside of your object. Okay, so if here's my radius, and then here is my toString. Basically, I'm just saying, okay, it's a circle, and the radius is set to this. So if you look at my circle test class, I'm printing out the toString method down here, but if I wanted to know right away like what values are stored inside of those objects, I can just call my toString and somehow. So I'm gonna make C1, I'm gonna make C, C2, C3, and C4. And then I'm gonna just say 4.35. We'll make this one 7.8. Oops. And this one we'll just say like 119. I don't know. Okay. And I just wanted to know what the current state of each one of those things are. I can just say print line, and I can just say like C1, which I don't actually have a C1, but I'm going to say that C is my C1, and then put in my object right there, right? And that's going to give me a preview of what data is actually stored in that object after instantiation. So 2, 3, 4. Go ahead and delete this line right here. Okay, save that, hop over here, clear, compile, run. All right, and then there's my toString showing you that each one of my objects has a different radius, right? I instantiated 4 circles, and I'm just printing out what the radius is. I can call this set, I can call set, and then I might want to just know what's inside of that radius. It's just it's a good way to debug or get a preview of what is inside of that object. Constructors. As mentioned previously, a constructor is used to set up an object when it is initially created. A constructor has the same name as the class. The die constructor is used to set the face value to the die constructor is used to set the initial face value of each new die object to 1. We examine constructors in more detail later in the chapter. Okay, so what the constructor does is it's the method that is called whenever you first instantiate an object. Okay, so the way this works, right, the way Java sees this is you create this object reference variable that you want to hold a circle. Then you tell Java new, meaning you want to put a new object into memory, right? So Java's going to put it into its memory, and the constructor is, which matches the name of the class, is going to be called, and the constructor is going to set up the object. Right, if there's any steps that need to be done to set up the object, the constructor is going to do that. So if you go to our circle class, what our constructor actually does, it's really simple. It just takes whatever value that was passed in and sets that value to radius. Okay? Or actually, it sets radius to that value. Got that mixed up. So the first object I created over here, I said was 9.5. So the R is holding 9.5. That 9.5 is being assigned to radius, okay? And then that object is being put into memory with the radius of 9.5. And then when I call my toString right here, you can see the output where there's 9.5 as the radius. This next object, I'm passing in a 4.35. So where this R is at, there's a 4.35. That 4.35 is then assigned to radius. That object gets put into memory, and it has a radius of 4.35. Okay, so even though I'm using the same class, there's multiple objects of circle inside of memory. So if I were to draw that up, okay, now remember, a class is a blueprint for of an object. So if I was gonna like draw a blueprint, right, it kind of looks like that, like scroll. All right. So just think of Java as just, like somebody who's just having to decipher what it is you want to do. Okay. So here's Java. It sees your code where you want to construct an object. It's going to look at your class as the blueprint and say, okay, I'm going to make an object based off that constructor that he gave me. And the constructor was new. And then I said circle. And I passed in a 9.5. And then Java's then going to put here's your memory on your computer. It's going to put a new circle like right here inside of memory. And inside of that particular circle, there's a radius thing. You can't see that. There is a radius of 9.5. Okay. The next one we said was 4. I don't know. I can't remember. I'd say 4.3. Okay. Java's going to look here. It's going to look at that constructor, compare it to the blueprint, find out what it needs to do to construct that object, throw that object into memory. So here is the circle number 2 that has the radius of 4.3. All right. Then and so on and so on. I made 4 of these things, right? So if I had one, like another one with 7.8, then it's also going to be put in memory to say like it was right here inside of memory. Okay. And that one is going to have a radius of 7.8. All right. So it's using this blueprint, the same blueprint, to create multiple objects. Now, for this particular object, when I say give me the area, the value of area is going to be different for this one. The value of area is going to be different for this one and this one because of their own objects. The class is only the blueprint that tells Java how that object actually behaves and what type of data it's going to maintain. All right. So it's like it's like a house, right? You have a blueprint for a house. You can make multiple houses from that blueprint. All right. We made a blueprint for a circle, and we're making multiple circles from that blueprint. Okay. We call get radius on an object. It's going to get radius from whatever it has set as radius, 9.5. So this get radius is going to be different from this get radius, which is going to be different from this get radius, right? This area is going to be different from this area, which is going to be different from this area. Right? It makes sense. This blueprint just simply tells Java how those objects behave and what type of data it's going to maintain. All right. Questions on that? So some students get confused thinking, here is my circle. I can only have one circle. Like it just defines just one singular circle, but it's really just a blueprint that tells Java how the circle behaves. Your constructor, you're telling Java your constructor is going to take in a float, and this whatever value is passed in, it's going to take that value and make your radius equal to that value. Right here. You have a set radius. It's going to take in a value and assign that value to your radius. You have your get radius. It's simply just going to return whatever radius is. Your diameter, it's going to take whatever your radius is multiplied by 2, right? And then your circumference is going to do this equation. Area is going to do this equation. So when you look back at this design, right, your get circumference here is going to be different than your get circumference here, which is going to be different from the get circumference here, right? They're going to all be different values, but this blueprint is actually telling Java that that object has a circumference method on it, has a diameter method on it, has a radius instance data that it's keeping track of. Okay, that's the way all this works. It's important to understand that. So the class, this circle.class, is simply just a blueprint of how we're going to design a circle object. Right, so here are our circle objects. All right, here, there, and here. All right, then we move on. That was a constructor. That's the way that works. Okay, scope of data. This is a little difficult to explain, I guess, or I don't know. It's actually pretty simple, but I'm just going to read the slide, and then I don't know if I have an example of this anywhere. Okay, the scope of data is the area in the program of which the data can be referenced or used. Data declared at the class level can be referenced by all methods in that class. Okay, so what they mean here is circle in my circle class, I have radius declared at the class level. So all my methods, all these methods below it can see the value of radius. Okay. All right. Data declared within a method can only be used in that method. Data declared within the method is called local data. The die class has a variable result is declared inside of the toString method. It is local to that method and cannot be referenced. Okay, so what they mean by a local data would probably, let's just say for this area right here, I just wanted to take, I made a float called radius squared. Okay, and I set radius squared equal to math.pow, and I casted it to a float. Okay, so I declared what we call a local variable, meaning this radius.squared only exists within this method, right, where those curly braces are. So then I can use this radius.squared right there in place of where I had my math.pow. Okay, so now I have this local variable called radius squared. I use it here. Once the method is done executing, that variable goes away, right? There's no way for me to reference it again. Okay. It doesn't like keep existing for the class. It's created every time you call the method area. Right? Just gets created there, and then when the method is done, it no longer exists. There's no way to reference that data. All right, that is a local variable. Instance data. A variable declared at the class level, such as face value, is called instance data. Each instance object has its own instance variable. A class declares the type of data, but it does not reserve memory space for it. Each time a die object is created, a new face value variable is created as well. The objects of the class share the method definitions, but each object has its own data space. That's the only way two objects can have different states, right? Which is different instance data. So this slide right here is pretty much just explaining like what I did here, right? We declared 3 circles. Java read the blueprint and put those circles into memory. I know this looks like a complete mess now, but you can see you have a circle in memory with a radius of 9.5, one with 4.3, and one with 7.8. We can depict the 2 die objects from the rolling dice program as follows. So they're saying the die 1 points to some die object in memory with a face value of 5. Die 2 has a face value of 2. Each object maintains its own face value variable and thus its own state. UML diagrams, I'm not going to talk about this. You don't have to know anything about UML diagrams. You will, though, in future programming classes. I'm just going to skip that. It's just a way to design classes, but I just think that it's just right now, like learning classes for the first time, I just think it's unnecessary. All right, so quick check. What is the relationship between a class and an object? Anybody know what the relationship between a class and an object is?
Class is sort of a blueprint.
Exactly. The class just defines how the object behaves and what data it's going to maintain. I'm just going to read what it has here. A class is a definition / blueprint or pattern / blueprint of an object. It defines the data that it will be managed by the object, but does not reserve memory space for it. Multiple objects can be created from a class. Each object has its own copy of its instance data. All right. Where is instance data declared? At the class level. All right. What is the scope of instance data? This is a tricky one. I wonder what the book says. So the scope of instance data is, think of, when they say instance data, just think of it as for the instance of an object. So that data only exists as long as that instance of the object exists. Meaning as long as you have a valid reference. So you instantiate an object, C1, okay, then the instance data for C1 only exists as long as you maintain a valid reference to that object. Local data is just simply variables that are inside of methods. They don't exist outside of that method. All right, so where does instance data exist at the class level? What is the scope of instance data? It can be referenced in a method of the class. Okay, they're just talking about referencing. I'm thinking more theoretical. But they're basically saying if you have radius declared at the class level, then any of the methods inside of this class will be able to reference radius. All right, and that is it. The next topic is encapsulation. So the whole idea behind encapsulation is we have our instance data like inside of this object. We don't want to allow anybody to directly manipulate that data, so we provide getters and setters to get that information. Unfortunately, we don't know anything about chapter 5 and 6 just yet, but if we had our radius data encapsulated, meaning encapsulation means we're making it private so that we can't directly access that data, only through the getters and the setters, we can maintain some type of integrity for that data. And by integrity, I mean what values do not make sense for a radius? Anybody know? Or any type of dimension, what doesn't make sense? Like 0 or anything less than 0, right? Like a negative value, right? So we can do something like this. Once we get into chapter 4, we can say if R is greater than 0, oops, what the heck? We'll put a dot. If R is greater than 0, then and only then will you set the radius equal to R. You're gonna have to put the same check in your constructor, okay? But in the constructor, it's a little weird because the whole reason we created that constructor was we wanted to initialize the data to something that made sense. So if we don't initialize it to anything, then we need to come up with some default value, perhaps a 1, or perhaps when we get to Java 2, we covered chapter 13, we can throw an exception, right? But it's just, as a programmer, you have to think, okay, I have this data for radius. I want to make sure that value never turns to something that doesn't make sense for a radius, like a 0 or a negative value. Unfortunately, though, we are not going to do any of this stuff until we get to chapter 5 and 6. So don't worry about it, but that's the idea behind encapsulation. All right, any questions? All right, that's all I have. Make sure you continue working on that quiz. I want it turned in tonight. I'm serious about it, okay? Because I know you guys aren't going to wait till the last minute to do your chapter 4 homework, so I want to make sure that everybody's getting exposure all the time, okay? All right, you guys are free to go. Get that in before, I give you until the start of next class to get it in. When I come in on Wednesday, I'll look for it. I'll grade the quiz before Wednesday's class.